Okay, we now have our final presentation, which will discuss the future directions for the F-CUBED and TORWASH processes in industry. And I'd like to welcome back F-CUBE Project Coordinator, Dr. Heather Wray.
I will be very quick. I just wanted to summarize a little bit at the end of the day here some of the highlights that we've heard about in the other presentations and highlights of the project and what that could mean for what happens next after the project ends. So again, this is just another reminder of our process. So we apply a TORWASH hydrothermal treatment to very difficult wet residue streams. We dewater, we do this at pilot scale at relevant industrial sites to produce a liquid fraction that we can digest, to produce biogas and recover nutrients from, and solids that we can pelletize and use as fuel in a boiler. We did testing on site at 3 industrial locations, so 1 for each of the residue streams where they were produced. We did pilot scale work, which is really important. Continuous, long duration testing, processing these residues with our technologies, with our F-CUBE process. We pelletized the solids, and then we also looked at what's the quality of the pellets that we produce, and how do they perform when we combust them, so how much energy can they produce. And also, we analyzed the liquids as well, or we assessed how much biogas potential they had. So again, just a visual representation of kind of what it looks like. We start with a very wet biogenic feedstock. We TORWASH it, we produce a slurry, a mixture of solids and liquids, and then we separate it into a filter cake that has a much higher dry solids concentration, of course depending on the feedstock, and a filtrate that can be used in anaerobic digestion. These wastes are really problematic, and they're mostly water. And so what we see with our process is that we have a very significant reduction in terms of volume of the waste, and also a reduction in the moisture content as well. And that's really important when you start thinking about the disposal costs and the disposal logistics of some of these residue streams. So this is a really significant result, and was one of the main objectives of the project that we were able to achieve. So that's really encouraging. And it also just shows the value of this process for these parameters for industry. Dawa showed this slide before, but this kind of shows also, this is sort of typical for many of these wet residue streams. After our TORWASH process, what we see is that a lot of the salts are washed into the liquid phase. And that's important because if they're not in the solid phase, that improves the fuel quality of the solids and the pellets that we produce. The goal of this project was really to recover energy from these residues that have a very low energy density as they're produced. All the solids could be pelletized to varying degrees of success. I will add that disclaimer. For example, the olive pellets were a bit, they were quite soft. They weren't very durable. When we shipped them to Ireland, they kind of disintegrated on the trip. But for orange and for paper sludge, we produce very, very good quality, durable pellets. And what we also saw is that the quality of these pellets was quite good, considering the residue streams that we started with. And we're very close to quality standards for non-premium biomass pellets, especially for olive palm mace and orange peel pellets. And we do believe that with some further optimization, we could actually achieve the quality standards that we aimed for the pellets. The pellets are suitable for syngas production, and also the char that was produced, as you saw in Eddie's presentation, is also potentially very valuable. The liquid fraction is suitable for nutrient recovery, so in the form of struvite precipitation to recover phosphorus, but also very suitable for biogas production as well. And that's a really important thing also to factor into the energy recovery from the process. So the F-CUBE process overall was much more efficient than the reference processes for these residue streams, taking into account the energy from the pellets, but also from the biogas production. The environmental impact's also significant, so we had aimed for 50% greenhouse gas emissions reduction, and we did achieve that for all of the target residue streams, all of our feedstocks, for the F-CUBE process relative to the reference case. So that's really encouraging, and that's really exciting as well, as we think about scaling up the process or applying it to industry. There are some considerations, of course. So from a technical perspective, I think we're doing really well. Economically, the best business case and the best economic feasibility is with this paper sludge case. And a lot of that is due to savings in terms of this fiber sludge, which is quite valuable. We don't need to use that anymore as a dewatering aid in the F-CUBE process, and it can be used directly to make paper. Considering total value chain then, it's also important, we can consider use of hubs for the downstream processes, and that can be economically advantageous across a larger region. For seasonal feedstocks like the olive and the orange, the number of operation hours and that seasonality is really important for these feedstocks. So if you're only operating an F-CUBE process for part of the year when that feedstock is seasonally produced, you don't necessarily have the business case, let's say. It's not as economically feasible. So if we can increase operational hours by processing multiple feedstocks in a region again, or adapting process flexibility to accommodate multiple feedstocks, then we see advantages as well. Also, there's not one size fits all for our process. We want to consider custom cases for target industries or target residue streams. And that can improve efficiency. And the example of that is with this paper sludge, where they use the solids directly in a boiler on site. And so it's advantageous in the custom case to not pelletize it. If you're just going to burn it directly anyways, there's no need to pelletize the solids. Also, given what Marco found in his environmental life cycle assessment, and these considerable greenhouse gas savings and avoided emissions, there might be also some potential value, economic value, associated with those greenhouse gas savings in the form of carbon credits. And that's not something that we really investigated, but that could be something that comes into play in the future as carbon credits become more important and more in the field of play. As for TORWASH, the technology, so there's TORWASH, the spin-out company, and they're building this scale-up, as you saw this morning. It's a demonstration plant at a wastewater treatment plant for municipal wastewater sludge. And at TNO, we also continue to work with them and also to do more lower TRL research on the TORWASH process. And tying into F-CUBED, it would be great to even further improve the flexibility of the process, expanding the feedstocks, as we talked about, especially to accommodate differences in seasonality. More and more, we're using TORWASH as a pre-treatment to downstream processes because we see the quality of the solids. So maybe there's other uses for those solids besides just burning them. So for example, as Chuan shared earlier, to use them to replace coal in steel making, for example, or maybe there are other uses downstream. And also just further investigation, how we can use those solids, nutrient recovery. I think there's a lot of potential for the process. We're always open to new ideas and collaboration. And I think F-CUBED really showed the value of the process for certain residue streams in certain industry. But as with all research, we also end up with more research questions, and we see more opportunities of things that we can do. So I would encourage you to, the project is ending, F-CUBED is ending, but please, yeah, if you're interested in the publications that we have or the some of our other dissemination activities or our reports or our deliverables, which detail all of this stuff, even more than what you heard today, please check our website for that. And there will be more coming even after the project ends as we continue to publish our results. And if you have any ideas for how to apply some of these results or these findings that we have, of course, you can also always contact myself or any of the project partners. So thank you, and thanks for attending today, and thanks for everybody who joined online and who presented online. And thanks to our organizers, Mike and Chris and Chiro, and is Mario still here? No, but and our organizers here in Florence. So thanks so much, and I hope you enjoyed it.